Have you ever wondered why Elon Musk suddenly stopped talking about batteries and started focusing on something most EV buyers never think about? Not the software, not self-driving, not even the battery, the motor. The one component hidden beneath every electric car, and what Tesla has just done to it could reshape the future of the entire EV industry. Because while most automakers are competing over bigger batteries and longer range, Tesla has been quietly solving a problem that could eventually limit the production of millions of electric vehicles worldwide. A problem involving rare materials, global supply chains, and a hidden dependency that most people don't even know exists. And the solution Tesla is building may make future EVs cheaper, more scalable, and less dependent on critical resources. So what exactly has Elon Musk changed? And why are engineers around the world paying close attention? Let's find out. For years, Tesla has been known as the company that pushed electric vehicles into the mainstream. But what's fascinating is that Elon Musk wasn't always an EV believer. Back when gasoline vehicles dominated the roads, electric cars were often dismissed as slow, impractical, and expensive experiments. Most people couldn't imagine a future where EVs would replace traditional vehicles. Yet Tesla bet everything on that future. And today, the results speak for themselves. Millions of Tesla vehicles are driving across roads worldwide. Gigafactories continue expanding across multiple continents, and what was once considered impossible has become the new standard for the automotive industry. But here's the interesting part. Tesla's biggest advantage wasn't just building electric cars, it was continuously improving the technology hidden inside them. And to understand why Tesla's newest motor matters so much, we need to go back more than a century. Long before Elon Musk, long before Tesla Motors, back to a scientist whose ideas were decades ahead of his time, Nikola Tesla. In the late 1800s, Nikola Tesla introduced a revolutionary concept, an electric motor that could run using alternating current. No steam, no combustion, no smoke, no fuel, just electricity and magnetic fields working together. At a time when industrial machines were noisy, dirty, and mechanically complex, Tesla's motor looked like technology from the future. Many people didn't fully understand its significance back then, but that invention would eventually become the foundation of countless modern technologies, including Tesla's electric vehicles. More than 100 years later, Elon Musk and Tesla revived that same vision. But they didn't simply copy Nikola Tesla's work, they modernized it. And that journey began with Tesla's first production car, the Roadster. When the Tesla Roadster arrived, the automotive world wasn't expecting much. Most people assumed electric cars would always be slower than gasoline vehicles. Then they drove one, and suddenly everything changed. The Roadster used a brushless AC induction motor, a design that delivered something many drivers had never experienced before: instant torque. The moment you pressed the accelerator, power arrived immediately. No waiting, no gear shifts, no engine noise. Just instant acceleration. It felt completely different from traditional vehicles. And Tesla introduced another feature that seemed almost magical: regenerative braking. Instead of wasting energy when slowing down, the motor could capture some of that energy and send it back into the battery. The car was essentially recovering power while driving. At the time, it felt revolutionary. But Tesla's engineers quickly discovered something important. The system wasn't perfect. As speeds increased, the motor demanded more electrical current. More current generated more heat. More heat required additional cooling, and greater energy consumption reduced efficiency. The Roadster had proven electric cars could be exciting, but Tesla knew the technology still had room to improve, and that's exactly what happened next. When Tesla launched the Model 3, most people focused on the price. What they didn't realize was that one of the biggest breakthroughs was hidden beneath the vehicle. Tesla had developed an entirely new motor architecture, a design focused on efficiency as much as performance. This new motor used powerful permanent magnets combined with an advanced engineering layout that allowed it to operate more efficiently than the company's earlier systems. But the hardware was only half the story. The real magic came from software. Tesla transformed the motor into something far smarter than a traditional mechanical device. When driving through city streets, the system could prioritize torque and responsiveness. When cruising on highways, it could automatically optimize for efficiency and range. The motor constantly adjusted its behavior depending on conditions. In other words, Tesla wasn't just building motors anymore. It was building intelligent motors, machines that could think, adapt, and optimize in real time. And that improvement helped Tesla increase efficiency, reduce energy consumption, and improve overall vehicle performance. But just as Tesla seemed to have solved one problem, another challenge appeared. A challenge that affects nearly the entire electric vehicle industry. And it revolves around a material called neodymium. Most EV drivers have never heard of it, yet it's one of the most important ingredients inside many modern electric motors. Neodymium is a rare earth element used to create extremely powerful magnets. These magnets allow motors to become smaller, lighter, and more efficient. They're one of the reasons modern EVs can deliver impressive acceleration and smooth performance. Sounds great, right? Not exactly, because neodymium comes with several serious problems. First, it's difficult to obtain. Mining rare earth elements requires extensive processing and can create significant environmental damage. Second, supply is concentrated in a limited number of regions. That means global production depends heavily on a relatively small portion of the world. And if supply becomes restricted, costs can increase dramatically. Suddenly, a material that helps power electric vehicles becomes a major strategic risk. Tesla saw this problem early, and instead of waiting for it to become a crisis, the company started searching for alternatives. This is where the story gets really interesting. Because Tesla's next move isn't about making motors stronger, it's about making them smarter. The company has been exploring ways to reduce dependence on rare earth materials by using alternative magnet technologies. One of the most promising possibilities involves ferrite magnets, also known as ceramic magnets. Now, here's the surprising part. Ferrite magnets are not futuristic technology. They're everywhere. You can find them in common household products. They're cheaper, they're widely available, and they're significantly easier to source. The problem? They're weaker. Much weaker than neodymium magnets. For years, that limitation made them unsuitable for high-performance EV applications. But Tesla isn't approaching the problem the traditional way. Instead of relying solely on stronger materials, Tesla is redesigning the motor itself. Advanced software, smarter magnetic layouts, optimized motor architecture. Every component working together to compensate for weaker magnets. In simple terms, Tesla wants intelligence to replace material dependency. And if successful, the implications could be enormous. Future electric vehicles could become less expensive to manufacture. Supply chains could become more resilient. Production could scale more easily across the globe. And perhaps most importantly, the environmental impact associated with rare earth mining could be reduced. That's a massive advantage if Tesla hopes to build millions, or even tens of millions, of future vehicles, especially as the company continues working toward autonomous transportation networks and large-scale EV adoption. And this brings us to the most important lesson in the entire story. Real innovation isn't always about inventing something completely new. Sometimes it's about taking an old idea and improving it so dramatically that it changes the future. Nikola Tesla imagined a world powered by electricity more than a century ago. Elon Musk and Tesla took that vision and pushed it further than anyone thought possible. Not through flashy announcements, not through loud marketing campaigns, but through thousands of small engineering improvements that quietly transformed an industry. And before we continue, if you're enjoying these deep dives into future technology, EV breakthroughs, and the innovations shaping tomorrow, make sure to subscribe to Modern Discovery and join thousands of viewers exploring the future with us. Today, Tesla's motors do far more than simply spin wheels. They recover energy, optimize performance, adapt in real time, and may soon operate with far fewer rare earth materials than ever before. That's why Tesla's latest motor developments matter. Because this isn't just about making cars faster, it's about building a future that is scalable, sustainable, and accessible on a global level. The next revolution in electric vehicles may not come from bigger batteries. It may not come from self-driving software. It may come from a component most people never think about: a motor, quietly spinning beneath the car. Just as Nikola Tesla imagined over 100 years ago, and once again, quietly changing the world. Thanks for watching, and we'll see you in the next episode of Modern Discovery.